Hi everyone. Thank you for a great opportunity for today. I would like to present my paper in International Webinar Digital Architecture 2021. This title is Spatial Configurations Approach for Predicting Office Layout Plan. It is authored by Nova Asliana, Melania Lidwina, and Nova Chandra Aditya. And this is our main ideas to take government office, especially in architectural design competitions for our case study. Its locations in Kabupaten Tulang Bawang Barat. That's these competitions from Indonesian Architect Association. As we know that there are some facts about our layout government office that's more formal, more hierarchy, and more systematic position. In this paper, we would like to have special configurations which it can examine these spatial hierarchies and structural organization to examine the spatial depth and also to predict a possible configuration spatiality. And for this approach, we use spacing tools. These are plugins for spacing in Grasshopper that provides for analysis, integrations analysis, control analysis, entropy analysis, and choice analysis. And we consider that there are some opportunities. This is as design strategy for a designer or architects, considering the possibility in early stage of spatial configurations to optimize spatial programming. Then the interpretations of spatial organizations and arrangement that is drawn as a bubble diagram, and it generates alternative or iterative spatial configurations that represents accessibility, spatial depth, and programming. There are five purposes. First, it creates a well-functioning spatial layout. It leads to permeable and accessible patterns of considerable layout spatiality. It predicts a suitable zoning in schematic design planning, and it evaluates configurative space to optimize spatial programming. And the last one, it identifies the spatial depth to determine how to identify the spatial depth to determine how to configure the space list into a simulative programming. There are three stages in our research methodology. Firstly, identifying variables for spatial modeling, and secondly, generating spatial configurations modeling simulations, and the last one, resolving spatial depth. For the first stages, there are four fixed variables like the given room list, the restrictions tool, area, the area each room, and the drawn connectivity. These variables will generate the translation for this into spatial configurations. And for the second stages, the result of the first stage will be used, and we add some tools like entropy analysis. It refers to reachable space. The higher entropy value identifies, the more difficult to reach this space. For integrations analysis, it refers to private or communal space, and the control analysis, it refers to show how strongly the vertex or the node is linked to other points, right? And then the last one, the choice analysis, it identifies how often a node happens to be on shortest path between other space, and it also measures the choice degree of space. And finally, for all those stages, will result a spatial depth, which means that we'll calculate the total number of spatial configurations and also the level of connectivity step depth. And we will conclude that we can generate how private and communal this group. And this is the first stages. We identify variables for spatial modeling. Actually, there are 11 departments, structural organizations in government office, but we only consider three departments as representative because they have similar rooms and then they have similar needs, and also public and social facility is the main aspect that need to be considered deeply based on the requirement needs during this competition. To commence with, we should set up the variables like the given room list, the restrictions total area, the area each room, the connectivity room, and should be drawn by the helping control tools in rhinoceros. And also there is the control tools in special modalities such as not link, grab points, and links. We can see that the navigation grab for spatial planning and also the pseudocode for this spatial modeling. And we continue to the second stage is generating spatial configurations, modeling simulations. From those pseudocode, it will generate the four analysis. We can see that the A facilities, manpower and transmigrations office, the living room or ruang tamu has the highest index for integrations analysis, means that this room are most communal room. And then the living room also has the lowest entropy index, means that this room are the most reachable area. And also this living room has the highest choice and control analysis, means that this room are most selectable area as the shortest path for users. And also this room has the strongest node to link other potential rooms in spatial configurations. And for the B area is populations and birth control office. We can see that the meeting room has the highest integrations, means that this room are most public room. And also this room has the lowest entropy index, means that this room is more reachable, the most reachable room. And also the living room in this office has the highest control, means that this room has the strongest node to link other potential rooms. But the problem is this room has the lowest choice index, means that this room are the most unselectable area for the user as the shortest path. And for the C facilities is social and public facilities. We can see that the MAS has the integrations index, means that this area are the most public. And then it has also the lowest entropy, means that this room has the most reachable area. We can see also that the open space has the highest control index and the highest choice index, means that this room are most selectable area as the shortest path for user and also has the strongest nodes to link other potential room in spatial configurations. And this second stage already we will generate spatial configurations based on alternative and iterative spatial programming. We can see that there are some nodes or vertex in our modeling. And final stages that will result spatial depth, means that we can know that the level connectivity value and calculations of the total number of spatial configurations that's contain the axial line of rooms. We can see that for the manpower and transmigrations office, this is the lowest flow of movement because it has 7 step depths, means that there are 6 space to be passed through to reach that room. And we can see also that populations and birth control office, there is 6 step depths, means that there are 5 space to be passed through to reach this room. And also we can see that public and social facilities, there is a 5-step depth, means that there is 4 spaces to be passed through to reach this room in this area. And we can see that public and social facility is the highest flow of movement for pedestrian compared to other facilities. And the conclusions for this paper for these investigations, first, considering the findings are that experimenting in spatial configurations approach is a developing strategy to understand deeply the spatial arrangement for the functions programming of government's office. Secondly, three fixed aspects that designers or architects should be considered, such as the sizable rooms, the restrictions each room, the total area, and the generator tools to analyze these variables. The total number, the analytical tools, and the final destinations of room could be changed or adjusted based on the needs or designer's preferences in how to justify the special step steps. And the third, it offers and helps designers to predict and calculate a simulated programming layout, which leads design to more appropriate, more accessible, well-functioning, and more user pedestrian friendly in office designing. And fourth is this tool is helpful and applicable for a designer or architects in pre-design phase to assess the room eligibility and validity, especially in early stage design process that's concerned on connectivity, permeability, and accessibility. They can apply and interpret the results into the next process design. This strategy can be taken account how to create the facilities more communal and accessible for users. And the last one, we conclude that this method serves as a validator in finding optimum spatial configurations for office layout master plan before developing design phase. Consequently, it modifies the mechanisms to iterate and evaluate the impact of spatial design proposal into the accessibility and permeability levels based on router preferences. Okay, this is the end my presentation for today. Thank you for your time.